Okay, so if you're in nursing research, you know the feeling. You're just staring at this mountain of raw data. We're talking patient stats, survey responses, clinical observations. It's just chaos, right? But here's the thing. Hidden inside all that chaos are the patterns that can literally revolutionize patient care. So, the big question is, how do we actually find them?
So how do we do it? How do you take this massive, messy pile of information and turn it into something that could actually save a life? Well, the answer isn't some kind of magic trick. It's actually a super systematic process, a way of creating order and finding real meaning in all that noise.
Think of this flowchart as our roadmap for the whole research journey. It takes you from gathering all that raw info right through to drawing the final conclusions. And today, we are zeroing in on one absolutely critical stage, right there in the middle. Step 5, the classification of data. This right here is where the real work of organizing everything truly begins.
So what in the world is data classification? Well, honestly, the easiest way to think about it is just sorting stuff. Seriously, you take all that raw information and you start arranging it into neat, logical groups, what researchers call homogeneous groups, based on what those pieces of data have in common. It's the tool that turns a total data storm into a clear, understandable map.
All right, so when we start this sorting process, the very first step is a big one. It's what we're calling the first big sort. Basically, all data, I don't care how complex it seems, can be split into two main categories. This is the fundamental first choice every single researcher has to make. And here they are. On one side, you've got qualitative data. This is all about, well, qualities. It's descriptive stuff, attributes, things you just can't stick a number on. Then, on the other side, you have quantitative data, which, as you can guess, is all about quantity. It's numerical, it's measurable. A great way to think about it is the difference between describing a patient's mood versus just recording their body temperature.
Okay, let's dive into that first category, shall we? We're going to start with classifying by attributes, which is all about understanding qualitative data. The name kind of gives it away, right? Qualitative data is purely descriptive. It's focused on the quality of something, not the quantity. We're talking about those characteristics that give us all that rich context and depth, but they just don't fit into a neat little numerical box.
So what does this actually look like in a nursing setting? Well, think about things like a patient's sex or their marital status, or maybe their religion, or even their literacy level. It could even include more abstract ideas like honesty. See? These are all super important pieces of information, but you can't exactly measure them with a ruler or a scale.
And we can get even more organized within this descriptive world. A simple classification is just what it sounds like. You look at one single attribute. For example, you divide a group into literate and not literate. Easy enough. But then there's manifold classification, which is where things get really interesting. Here, you're looking at two or more attributes at the same time. This is how you start to see how different traits might connect, like maybe looking at literacy levels and gender together.
All right, let's hop over to the other side of that big data divide. We're going to switch gears now and talk all about quantitative data. This is the world of numbers, counts, and measurements. So, quantitative data is pretty much anything that you can express as a number. It's all about a quantity that you can measure with a specific unit. Things like kilograms, degrees Celsius, or even just counting the number of patients on a ward. But here's a really important point. Not all numbers are created equal. We have to break them down into two key types. First, you've got discrete data. This is stuff you can count in whole numbers. Think about the number of children in a family. You can have 2 or 3, but you can't have 2.5. Then you've got continuous data. This is stuff you measure, and it can be any value within a range, like a person's height. This really boils down to that key difference between counting and measuring. We count discrete data, like the number of patients in a ward or the number of kids in a family, but we measure continuous data. That's things like a patient's height, their body temperature, their serum cholesterol, or even their age.
Now, imagine you have a ton of quantitative data. Like, let's say you have the exact age of every single patient in a hospital. Listing each one out would be a nightmare, right? It's just not practical. So what we do is we group them into something called class intervals. A perfect example is creating an age group for everyone between 20 and 30 years old. It just makes these huge data sets so much easier to handle.
Okay, so we've got our big split, qualitative and quantitative, but we're not done yet. We can actually get even more precise. There are 4 distinct scales of measurement that add these deeper layers of meaning. And this is really important because which scale you use determines what kind of statistical analysis you can even do later on.
So these 4 levels are nominal, ordinal, interval, and ratio. The best way to think of them is like steps on a ladder. As you climb up, each step gives you more information and more statistical power than the one below it.
This table just lays it all out so perfectly. Let's do a quick walkthrough. So first up at the bottom of our ladder is nominal. This is the simplest. It's just categories with no order, like gender or marital status. Step up to ordinal, and now you have categories that have a rank or order, like a pain scale from 1 to 10. Next, we have interval. This has order and it has equal spaces between the values, like temperature and Celsius. But, and this is key, it doesn't have a true 0. And finally, at the very top, you have ratio. This has everything: order, equal intervals, and a true 0. Think height or weight. That true 0 is a huge deal, because 0 weight literally means the absence of weight.
Okay, so we've gone through all these categories, all these different scales, and you might be thinking, so what? Why does any of this matter? It's a fair question. Let's connect all this theory back to the real world, back to what actually matters in practice.
I mean, this quote really says it all, doesn't it? Classification helps in making comparisons and drawing meaningful conclusions. Think about it. Without this kind of organization, you just have a big, messy jumble of facts. But once you classify it, you can start to compare groups, analyze outcomes, and draw conclusions that are actually meaningful and reliable.
And this is the real takeaway. At the end of the day, classifying data correctly is not just some boring academic exercise. It is the absolute foundation, the bedrock of any valid research. And it's that research that leads to the evidence-based practices that directly improve patient outcomes. It's a straight line from sorting data to better, safer patient care.
So that brings us to our final thought. A question for you, really. Now that you have these tools, this framework for organizing information, just think about your own practice for a second. What patterns are just sitting there waiting to be discovered? What questions could you answer if you started classifying the data that's all around you every day? Because those insights that can truly improve patient care, they're out there. They're just waiting to be found.